Class 10. Example sum 5.16. Prove analytically that the line segment joining the midpoint of the two sides of a triangle is parallel to the third side and is equal to half of its length. We have to prove this, that ST is parallel to QR and the line ST is half of the line of QR. We want to prove that, right? Let me take it as, let S be the midpoint of P and Q and T be the midpoint of P and R, that is PR. Now we want to find the midpoint. We know the formula for midpoint. What is the formula? X1 plus X2 divided by 2, Y1 plus Y2 divided by 2 is the midpoint formula. Now P and Q, the point P and Q, the midpoint S from the point P and Q, we want to find the midpoint of S. The midpoint S is equal to, we have the formula the same, right? Let me take it as first point as x1 y1, second point as x2 y2, right? So A plus C, x1 plus x2 divided by 2, y1 plus y2 b plus d divided by 2. This is the point of S. Then midpoint of T is equal to, we know the point, midpoint is P and R point is the midpoint. Then P is A, B and R point is E, F is given. Let me take it as x1, y1, x2, y2. x1 is equal to A plus y1 is equal to x1 is equal to A, x2 is equal to E divided by 2, y1 is equal to B, y2 is equal to F divided by 2. This is the point of midpoint of S and T. Now we have found out what is the S and T point. By using these two, we have to find the slope. The slope of ST is equal to, when 2 points are given, we know the formula, that is y2 minus y1 divided by x2 minus x1 is the slope point when 2 points are given. Let me take it as, this point as S and T, this point is x1, this point is x2, y1, this is x2, y2. Now I applied in that y2 is b plus f divided by 2 minus y1 is b plus d divided by 2 whole divided by x2 is a plus e divided by 2 minus x1 is a plus c divided by 2. See, in numerator and denominator we have the same number, that is 2, so directly we can add or subtract the numerator, right? By this condition, this term is equal to, I take base denominator 2 whole divided by c. Here b plus f, here we have minus of the second term, so minus b minus d, right? And then here the denominator also we have the 2 common, a plus e minus of the second term, minus a minus c. So in numerator and denominator we have 2, the 2 will be cancelled, then b plus b minus b will be cancelled, here plus a minus a will be cancelled. See, in the numerator we have f minus d, in denominator we have e minus c, that is slope st is equal to, that is slope st. We want to find out what is the slope of QR. We want to find this slope of QR because we want to prove that ST is parallel to QR. Next we take the Q and R point. We want to find the slope QR is equal to, see that y2 minus y1 divided by x2 minus x1 is the formula when 2 points are given. First point we take as x1 y1, second point we take as x2 y2. Now y2 is equal to f minus y1 is equal to d divided by x2 is equal to e minus c. This is the slope of QR. Now see the slope of QR, and this is E minus C, right? F minus D divided by E minus C. And then slope of ST is equal to F minus D divided by E minus C. Both are equal, right? Therefore slope ST is equal to slope QR. Therefore the line ST is parallel to QR. The line ST is parallel to QR. Next we want to find out the ST is half of that QR. The length ST is half of the QR. let me take it the distance between that distance. If you are finding the length means we have the distance between formula. Distance between QR is equal to Q point is we know that C, D, E, F. I write it here again. That is Q point is C, D and R point is E, F. The distance between we have the formula QR is equal to x2 minus x1 whole square plus y2 minus y1 whole square. When we are finding the length, when 2 points are given, this is the formula, right? Distance between. Now, let me take it as first point as x1, y1, second point as x2, y2. Now, x2 minus x1 is equal to root of E minus C whole square plus y2 minus y1 is equal to F minus D whole square. So, this is the distance between QR units, right? Now we want to find out the distance between ST. S we know the point and T we know the point, right? Here we have S and T point. The distance between ST is equal to again the same formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. So this is the point of S and T. The S point is A plus C divided by 2, B plus D divided by 2, and T is A plus C divided by 2, B minus F divided by 2. We want to find out x2 minus x1, A plus E divided by 2 minus A plus C divided by 2. And then y2 minus y1 is B plus F divided by 2 minus B plus D divided by 2 whole square. Here we have find out the x2 minus x1 whole square. Now see, inside the bracket we have, in the denominators are equal, so I take commonly the denominator. So here we have A plus E minus of the second term, so minus A minus C whole square plus, here also the same common term to B plus F minus of the second term minus B minus D whole square. Now here plus A and minus A will be cancelled, here plus B minus B will be cancelled, then this term will be, if I square the term, we get the numerator as E minus C whole square divided by 4 plus, here also we have F minus D whole square divided by 2 square is 4. I am squaring the numerator separately and denominator separately. Denominator when we square we get 4. So both we have the denominator 4. Here both the denominator having the 4, so I take it as commonly 4. If I take commonly 4 outside means it is in the root. When root 4 is equal to, we know that value is 2. So here in denominator 1 by 2 root of E minus C whole square plus F minus D whole square. See, this value is equal to root of E minus C whole square plus F minus D whole square is equal to QR. Right? The value is QR. Now in this place I apply the value, therefore the length of ST is equal to half of the length of QR. That is the condition. Therefore the length of ST is half of the length of QR, and then already we have find out that ST is parallel to QR, and the line ST is parallel to QR, hence proved. Thank you, students.